Well, the sun has gone through some interesting developments. We have one last phase, and it's the pretty one. So the sun does get to go out with a pretty sight. What happens? Remember when we stopped, we said that the thermal pulses were going to eject the envelope of the star. What we would be left with is the inert, not fusing, no energy source, completely degenerate carbon-oxygen core. This is an object. We'll talk about it. It's called it starts out life as what we call a white dwarf. It's got about the radius of Earth. It's got about the mass of the sun. It's extraordinarily dense. It's extraordinarily hot, even though no fusion is going on, because it just stopped being the core of a star that was fusing helium and hydrogen and so on, and was compressed by great masses. So this object has temperatures of many tens of thousands of Kelvin, and it is surrounded by the atmosphere that it ejected, which, since it was ejected, has been moving steadily out into space. What you have, therefore, is an expanding bubble of gas surrounding an object with temperatures in the tens of thousands of degrees. The ultraviolet light produced by this exposed core is, of course, going to ionize the gas that's been expelled. The ionized gas will then glow in the same way that the aurora glows and in the same way that lightning glows, and the resulting objects are some of the prettiest in the sky, so we're just going to spend a few minutes relaxing and viewing them because they are pretty. They're called planetary nebulae because they look round and in a small telescope. They look somewhat like a gas planet would. This is the Ring Nebula. We talked about it in our first video clip and promised to come back and explain what this beautiful object is. So what this beautiful object is in the middle sits a white dwarf star, and these are the ejecta that it formed. These planetary nebulae can be a couple of light years across before the material melts into the interstellar medium, taking with it some of the carbon and whatever that the star produced, dredged up and ejected in its solar wind. So they seed the planetary nebula is a star's way of seeding the interstellar medium with heavier elements. And we see here oxygen and nitrogen lines in the colors. The red is ionized hydrogen. These are the H-alpha lines. And at some point, people thought that this was sort of a slice through a spherical bubble of gas. It was discovered upon closer examination that, in fact, just like the T-Tauri winds, the planetary nebulae, the atmosphere of a star gets ejected, but not in a spherically symmetric way, but in a bipolar flow. So this thing has the shape of a cylinder. The axis of the star's rotation happened to have pointed at Earth, so we're looking down the tube of this cylinder. Other nebulae, we get a different view angle, so we get more of a picture of the structure. This is the Helix Nebula. The cat's eye is certainly instructive in telling you that there's more structure than just spherical. There's a lot of interesting questions here. This one is very nice. It's not the dumbbell, it's another one, but it does show very nicely the bipolar nature of the ejecta coming out of the star, and I believe this was a Christmas astronomy picture of the day. This is one whose intricate structure apparently follows from several generations of ejection of material, in between which the axis of the star rotated, perhaps because a binary partner was influencing it or something, so that we have ejections in several different directions, and the combination makes for this beautiful shape. Planetary nebulae, if nothing else, they're very interesting. They're also extraordinarily pretty, and we deserved some aesthetics before we move on with science.